Welcome everyone. My name is Gábor Kismámosi, and I'm the original author of the LVGL library and the CEO of LVGL LLC. In my presentation, I will talk to you about how to create your first UI project with LVGL using NuttX. But let's start with what LVGL is. So LVGL stands for Light and Versatile Graphics Library. So it's a graphics library which helps you to create beautiful user interfaces on resource-constrained embedded devices. I can proudly say that right now, LVGL is the most popular free and open source embedded UI library. It's a full-featured solution because it contains more than 30 built-in widgets, including bars, sliders, charts, buttons, drop-downs, keyboards, text areas, and many others. Basically, what you can see in an Android or iOS application can be realized with LVGL as well. Besides that, LVGL has a quite powerful style and layout system. These layout and style systems are heavily inspired by CSS. If you are not familiar with it, CSS is the styling scheme of the web pages. So the same technologies which makes the web pages so powerful and responsive are available in LVGL too. In the practice, it means that you can choose from more than 100 style properties to style all the parts of the widgets in various states, and you can apply transitions when the widget changes state. So you have a great freedom for deep customization on the appearance of the widgets. In case of the layouts, it means that LVGL adopted the most or the latest layout technologies of the web, meaning the flexbox and the grid layout. Using these layout systems, you can easily position the widgets, and you can also change their sizes automatically in a responsive way. LVGL also comes with a powerful typography system. It supports the Asian languages like Korean, Japanese, or Chinese, or the Arabic languages with right to left and left to right writing direction support. You can also mix the two. And of course, it supports the Latin-like languages as well. So as I already mentioned, LVGL is a free solution. Its source code is fully available on GitHub as well, and is distributed under an MIT license. In the practice, the MIT license means that you can use LVGL for commercial purposes as well without any issues. All you need to do is adding a sentence in your documentation stating that we have used LVGL to create the UI of this product, and you don't need to pay any licensing fees, subscription fees, royalty, or anything else. I also mentioned that LVGL is quite popular today. It means that according to the statistics on GitHub, we can see that LVGL is downloaded in every minute by someone. And besides that, it's already supported by the leading players of this industry, including the largest chip vendors and operating systems like NuttX as well. LVGL is platform independent. Therefore, you can use it with basically any modern microcontroller, microprocessor, with any real-time or normal operating system, and you can drive basically any kind of displays, like an OLED display, monochrome display, e-paper, TFT displays, or monitors, if you like. If you want to use LVGL on its own, you need to have software developer skills, because you need to call functions like button create, set position, set size, so you need to write code. However, there are multiple third-party UI editor tools that you can use to speed up the development process, with Squareline Studio, which is a subscription-based tool, or Easy Studio, which is a free and open source solution. You can use your mouse to put together a UI in a drag-and-drop fashion. And finally, I'd like to tell you a few words about the services that we are doing. If you like, we can help you with creating a UI design for your product, implement your UI with LVGL, of course, and if you have both UI designers and UI developers as well, we can help you with a consulting service to help you answering some questions, to help you to optimize the performance and things like these. On this slide, you can see a few demos that we have created with LVGL. However, if you click on this link, You can go to our new website. It was released just a week ago. And if you scroll down a little bit, you can see some demos here, which are actually interactive. So you can click on these switches, for example, drop-down list, and you can see how the widgets looks like and works in the practice. We have a keyboard here. This one is a password box. This is how the widgets look like out of the box. So for example, if you create a switch, it will look like this. But as I already mentioned, you have a lot of opportunities to change the appearance and customize it as you like. Here we have some charts that you can slide, and we have this popover here, a similar bar chart, and some gauges. We have used only a few images on this UI, therefore you can change the appearance, for example, the primary color, very easily in runtime as well. The other demo that I like to show you is a smartwatch that we have designed for NXP. It was created in Squareline Studio without writing a single line of code, so even a designer is capable of creating these UIs. And here we have a thermostat UI. Here we haven't used any images at all, so all these gradients and shapes and shadows were rendered by LVGL with its built-in software render engine. And we have the music player application. Here these jumping bars are quite interesting, I believe. Yeah, and the printer demo at the end. So at the beginning of this year, we have released LVGL version 9. It comes with a lot of great updates. For example, we have updated the rendering architecture. It means that now when LVGL wants to render something, it can use RTOS function calls as well during the rendering process. Therefore, it can free the CPU while, for example, a GPU is working in the background. Besides that, with the new rendering architecture, you can use multiple CPU cores for rendering as well. And finally, now we have some built-in assembly options to replace the slowest and most resource-hungry parts of the rendering with some dedicated assembly instructions. We also have built-in drivers in version 9. You can use the most popular display controllers like the ILI 9341 and the similar ones with SPI parallel port interface. These display controllers already have a frame buffer built in, so you don't have a lot of RAM inside your microcontroller. So if you have a display controller like this, you can just create an LVGL initialization code for it by a single line of code. Besides these low-level display controllers, you can also use some high-level drivers like Linux frame buffer, DRM, Wayland, and these kind of things. These are also just a single line of call, a single line of function call to create a new window where LVGL can render something. And finally, a few words about some rendering features and widgets. I like to highlight the new gradient engine. But instead of just talking about it, I can show it in our documentation. If you go to docs.lvgl.io, you can see a detailed documentation about all the main parts of LVGL with a lot of examples about the styles. So we are in the style section right now and looking at the examples. Here we have some examples for the new gradient engine. So now you can use this conic gradient, not just a horizontal or vertical gradient like in LVGL version 8. So without any images, you can runtime generate this nice effect. And yeah, maybe it's not obvious at the first look. Why is it better to use a software rendered gradient instead of an image? So if you're using a software rendered gradient, you can update it at runtime. You can change its colors. You can change any parameters. You can animate it if you like, and you don't need to embed a lot of images into your Flash. If you like, you can pre-render these into a RAM buffer to make rendering faster in general, but it's really up to you to decide how you trade off with memory and time. Here we have a radial gradient used as the background of the screen. And here you can see some other gradients applied on buttons. So this is the old and basic horizontal and vertical gradients. However, we have this linear gradient where the gradient has an angle, and you can see here a radial gradient where it even has an offset. The other feature that I wanted to show you is the Lottie animations. So the Lottie animation is something similar to GIF, but it's vector-based and full-colored. So the GIF images are using a 256 colored palette at best. However, with Lottie animations, you have the whole color spectrum with ARGB 8888 colors, and as it's vector-based, you can scale it as you like. To add this Lottie support to LVGL, we have used another library called SoarVG. This is quite popular already, and it has a lot of features for great vector rendering, Bezier curves, strokes, and all this kind of stuff. And it has support for Lottie animations as well, so it was quite handy to, once it's already integrated to LVGL, to use it for Lottie as well. As usual, similar to the other widgets, to create a Lottie animation, you just need to call a function like lvLottieCreate, pass a parent widget as a parameter, is the current screen right now, and you just need to set its data to some array where the actual Lottie animation is stored. And finally, you need to assign a buffer where the animation will be rendered. Here you can also control where you store this buffer in internal RAM, external RAM, so you can set it up as it fits the best to your system. Okay, let's talk about how you can use LVGL in NuttX. Here I also need to mention the great work of Xiaomi. You might know that Xiaomi have published their operating system called VillaOS, which is based on NuttX, and for UI they are using LVGL. So the Xiaomi developers or engineers have already contributed a lot into LVGL, but as they are using NuttX as well, they have added a very good NuttX support in LVGL too. What I mean by that, for displays, we support NuttX LCD interface and NuttX frame buffer device support as well. So in a quite NuttX-ish or Linux-ish way, you can just use the normal LCD device or frame buffer device and create an LVGL display for it. Similarly, for the input devices, you can use the input devices of NuttX, or we support UTouch as well. In case of images and fonts, sometimes you need to deal with cache mechanisms, because when an image is updated, you need to clean it from the cache. So LVGL supports NuttX Cache API as well to automatically invalidate or clean the cache when needed. We also have a profiler which helps you to show what LVGL does in a visual way. It will show some function calls, and the functions which are called from there, you can measure the time and see the whole hierarchy. And for this profiler, we have a one-liner initializer for NuttX as well. So you just need to call a function, and you can use LVGL profiler because all the timers, time measurements, and the printing and everything will be set up for you. If you would like to measure the CPU usage, normally LVGL can do it out of the box as well, but it's not aware of the operating system because it just measures how long did it take to execute some of its functions. However, if the operating system yielded a task and did something else in the meantime, LVGL doesn't know about it by default. So you can give LVGL a special idle measurement function, which will report the idle from the operating systems itself. To do this, we have ready to use NuttX function as well, so you can enable it quite easily. And finally, LVGL supports libuv as well, so all the power management related stuff for low power devices is available. You just need to enable a single config in LVGL's configuration file. Let's see how it looks like in the practice. So this is how you can set up a basic LVGL UI in the NuttX ecosystem. So first, we have a descriptor that we need to initialize to the default values. In the descriptor, you can set the frame buffer's path. Let's say it's the FB0 as usual. And you can also set a path for an input device. It can be a touch, it can be a mouse or something similar. After that, you need to actually create an LVGL display and LVGL input device from these settings. You can do it by calling lv-NuttX init, and the result will be stored here. Here you will find a pointer to the LVGL display and the pointer to the LVGL input device and all the related stuff. And finally, you just need to call a UV loop passing these results. So it will take care of everything, create the timer, pause it and resume it when needed. And that's it. Before calling this loop, you can add your LVGL UI code. We have a lot of built-in demos, built-in examples, so you can try out a lot of LVGL stuff out of the box. It's not really our merit, but the merit of the NuttX architecture, that you can very easily change between various architectures or devices, or let's say targets. So if you would like to try out LVGL on a Linux environment, you can configure it for simulator and targeting LVGL frame buffer. After that, you can just make it and run the NuttX application. Later, if you would like to switch, for example, to an ESP32 target, of course, you need to execute a clean, and after that, configure it again for the desired, in this case, ESP32 target with LVGL, compile it, and flash it to the ESP module. And this is how it looks like in the practice. So this is an ESP board where we have created a small intro animation. And this is a basic LVGL example to show you the scrolling and offsetted list. And that's it. And finally, I would like to tell you a few words about the things that we are working on right now. On the first slide, I was talking about that if you would like to use some UI editors, you can choose from some third-party solutions like Squareline Studio or Easy Studio. However, we realized that we should have our own solutions for this. There should be an LVGL official UI editor toolkit, and we have just started to work on it right now. In the past few months, we were working on the business background and the financial aspects, but a few weeks ago, we have jumped into the actual development. So this is how it will look like and how we imagined it. First, it should be a quite light and developer-centric UI editor toolkit. By developer-centric, I mean that we have clearly realized that designers are always using Figma. They are naturally into using some developer-related or close to development tools to put together the UIs in drag and drop fashion. They want to stay in Figma. Figma is the most popular UI editor, UI designer today. So all the designers are using it right now. So our goal is basically to create a good bridge from Figma to LVGL, because on a larger scale, usually there's dedicated designer team who created the design in Figma, and the developer's task is to re-implement it in, let's say, in LVGL. So our task is to help integrating the Figma design into an LVGL environment. As it's a developer-centric tool, it's very important for us to make it work very well with the normal and usual version tracking systems and have a good integration with GitHub, GitLab, or Bitbucket as well. Here I also need to mention that as it's developer-centric, the generated code, the quality of the generated code is very important for us. We just don't want to have some bulky and dummy and do not edit UI code from the editor that you cannot really touch, but this UI editor toolkit should work together with the developer. It should help you when it's really difficult to do something from code, because it's easier if you immediately see what you are doing instead of having 100 iterations like compiling, running to see if the positions are correct. So it should help you with the visual things, but should give you the freedom to implement the logic as you wish in code. We also realized that basically all the vendors are migrating towards VS Code. So this editor should work as a VS Code extension as well. But if someone is not using VS Code, we should have a standalone desktop application as well. Besides that, we will add a plugin system which will allow vendors or some OEM companies to add some custom plugins for their special workflows or hardware or anything else. And that's it about LVGL in short and how you can use it with NuttX. If you have any questions, please let me know. I would be happy to answer them.
It was a really nice presentation, and I want to thank you every time I see you, because I don't know if you remember, but about 7 years ago, 2017 or maybe 2018, I don't remember exactly, when I discovered LVGL, and I tried to start trying port it to NuttX, and I contact you, and you was very helpful to help, and actually you did the port to NuttX yourself, because I was not so familiar with the LVGL. It's still not so too much, but today I use it a lot, and it's a really good library. I developed a project a few years ago using LVGL, and it was in production in United States currently. And so, yeah, you deserve that success you have, because you are a really good guy and really smart and have great skill.
Thank you very much. Yeah, I do remember that first NuttX implementation or integration. Yeah, 7 years ago. Yeah, I published LVGL in 2016 on GitHub. So NuttX was the first operating system who integrated it, and it was. Yeah, and it was a big step for me as well. Yeah, you know, the first time working with a huge project, and I was super excited that LVGL will be integrated into something large, which is already existing and used by a lot of people. So yeah, thank you very much for that initial boost. It meant a lot.
Yeah, and I hope you come to our event in person in next year, because we are expecting you here. But we know it's a long trip for you, and you have family, and as you said, baby and small child, so it's a little bit difficult. But let's see for next year, and it should be nice, and we hope it happen in Europe, so it will in your neighborhood, in your
Closer.
yeah, very close, in your backyard.
Let's see what we can do.
Yeah, it would be very nice to meet you in person, guys, really. So I hope that we can make it next year.
Thank you. And about the this demo that you show, do you share it in GitHub that we can test? Because it seems really nice to see the NuttX logo showing up. Maybe you can do some like some default application with it, including NuttX, for example.
Sure. If you like, we can send you a pull request to the LVGL demo of the NuttX applications.
Yeah,
Should be interesting. Yeah.
Should be really nice. Really cool.
Okay, we can do that.
Let's see if we have some questions in the room. Does
Okay.
anyone have questions regarding LVGL?
Who he has tested or used LVGL already? Alison? Only Alison? Or maybe
I ran some samples, but nothing.
you use the default sample, but okay, not play with. Yeah,
I have a question regarding the major version and the last version. What did it actually change? We have more animations, demos, something like that.
In the last major version, which was version 9, we have changed the rendering architecture as I have described. It was the largest or the most impactful change, I guess, because now LVGL can work better with software rendering and GPUs together. So let's say the GPU can render something on one area of the screen, and the GPU can render this area, and the CPU can render another area in parallel. So the only limit will be the memory bandwidth. It was a huge update and required like rewriting the half library. Besides that, we have added a few widgets. We haven't really touched the style system, which is important because we are always having some breaking changes on the major versions, but at least the style system remained the same, so it's easier to migrate. We have also changed the driver layer a little bit to make it more suitable for the built-in drivers, make it more runtime. We have worked better with runtime display creation. Now you can change the color formats in which you are rendering in runtime as well. For example, if you have multiple displays connected to a single microcontroller, you can have one with eRGB 8888 and the other with RGB 565 color formats. So these are smaller changes, but still important. But if I needed to highlight something, it would be the new rendering architecture and the introduction of the vector graphics library SORVG that I have also mentioned. So now we have a lot of vector related stuff in LVGL as well.
cool.
Okay, just one more comment. I have been working LVGL since the version 7, I guess. So it's amazing. Yeah, it's just comments about that. So, but it's amazing. You're working. It's an incredible library. I have some advice for this room, please using the LVGL in your project. It's a very lightweight library, and the API also it's very powerful. So thank you, Gabo. Also, it's a pleasure meet you. And yeah, have a good weekend.
Yeah, thank you for the feedback. It's really happy to hear that you like it and find it powerful. It was really nice to see you guys. I hope you have found my presentation interesting. And next time, if you would like to do some UI related, I hope LVGL will be an option for you.
Okay, thank you, Gabor, for the presentation again. About the this breaking that you mentioned, for example, when I try to run some application from version 8 or 8.3, I need to do some modification to get it running in version 9. Do you have some plan to make something like OpenGL that more more freezing API, more that don't change too much over the time? Because it should be nice to have at least some basic API that we can rely and know that they are not to be deprecated or removed over the time. Do you have some plans or some idea for some free, like LTS or free zone version API?
Yes, actually, this concern was raised by the developers of Xiaomi already, because they are also suffering with the API breaking. Even if I consider these changes minor, if someone has a huge ecosystem where multiple applications, multiple products, multiple departments of the same company are using LVGL, it's a hell to, update everything and clean out all the libraries, versions, and align them again. So yes, to make it simpler for them and of course others as well, we have decided to keep the APIs backward compatible for 2 major versions. So even if we deprecate something, it will be introduced and you will have one new major version to adapt to the new API.
Yeah, it should be nice because, for example, I think the great benefit of NuttX, for example, is the POSIX. You know, if you develop something in POSIX 30 years ago and you can still running it today, and I think should be nice to have some great graphic library as LVGL, very stable, and we can use it for many years without breaking the code or modify things. Maybe the version 9 or after the version 10, it can be stable and you can add more function, but the basic function that is there is still the same.
Yeah,
Really
definitely.
good.
We need to pay more attention to this for to backward compatibility. And yeah, being POSIX compatible is, I think, the dream of all the developers to really do something now, and 30 years later it will still work because POSIX still POSIX. It's really awesome, I think, and makes a huge difference for developers, especially for large projects. I don't know the details, but I think it was one thing why Xiaomi, for example, have chosen NuttX, because it's so mature and
Exactly.
stable.
Yeah. Yeah, there are many other RTOS out here. If you go to Wikipedia, there's more than 2,000, and NuttX is one of the great RTOS exactly because it has this POSIX compatibility, and it really shine on that, and also be very similar to Linux, make things easier for people that are coming from embedded Linux, for example.
Oh,
Yeah.
yes. By the way, do we have a few minutes? Because I also would like to ask something. Yeah.
Oh,
Yeah.
yeah, we have.
Once NuttX is so Linux-like, I wonder if there is an option to install applications or run multiple applications as you would do on a normal PC. It's very important, for example, for smartwatch manufacturers, when like an alarm or a messenger or something like that can be installed or uninstalled in a dynamic way. Do you have an idea for this maybe?
Yeah, actually, my dream for a long time was create some NuttX distribution like you have for Linux,
Mhm.
and we can use like the OpenWRT, the for routers they have the OPK OPKG the package like the apt-get, so you can
Yeah.
install application and so on. And NuttX can do that because we have ELF dynamic loading application. So we can create something like that to create many applications and do like firmware update only for the application or one specific application, for example. And but I don't know. We have many names for this distribution, like Nutcracker or pistachio, many things related to nut. But we never have someone or many people interested to do that because it's not a project for a single person. I think it need to be like Debian. You need to have many developers engaged on this challenge because
I think that a proposal like this should go to the dev mailing list, and then we will see if people are interested in creating either a distribution or having the ability to run install multiple applications from external sources. There are a few ways of doing it. I think that the best would be to take it to the mailing list, and then we will see which option is better for us and what the other developers think about it.
yeah.
Okay. Do you also use the GitHub issue tracker actively, or rather the mailing list should be preferred?
We use it, but the preferred way is the dev mailing list, because then you have access to all the developers, and also the communication is archived so that we can document why we added something. So the primary channel is the dev mailing list.
Yeah, for general discussion, it's better to use the mailing list. But for example, we are using it actively for issues that people find, and we are fixing issues based on issues in the GitHub. But in this case, it's most like a proposal than an issue itself.
It's a feature.
It's a feature. It's not a
Okay.
bug. It's a feature.
Yeah, okay, clear. Yeah, this feature was actually requested by multiple smartwatch manufacturers from us if they can do it with LVGL, and I needed to tell that it's not really an LVGL thing how you replace a snippet of the binary on the microcontroller. If you can do it by adding two numbers, you can do it with LVGL too.
Yeah, actually, my previous idea was doing it using some like text or like curses test mode. But now that we are jumping with in the idea, we can do like a graphic installation like in Linux today, using the LVGL, and so the people can select I want this and this application and just build and create the final board with all the applications.
Let's take it to the dev list, and we should
Yeah.
also consider that most applications for NuttX are headless, and they are usually quite small, so
Yeah,
you
maybe-
cannot connect a display.
Yeah, I think it's like Linux, right? We have both scenarios.
Let's take it to the mailing list, and then we will see what
Yeah,
the project thinks that is the best way.
I agree.
Sure. Okay, we will. Maybe we will need some time to send it, but I will keep it in mind for sure.
Right. Are you in the NuttX mailing list? I don't know if you are already there.
Not yet, but
Okay.
yeah, I can.
I sent the link. Is in the nutx.apache.org. There's a community.
Let's send
Yeah.
the
We
link.
send the link and
Yeah.
you can. Yeah.
Okay,
can
awesome.
enjoy
Thank
it.
you.
Thank
Super.
you
Thank you.
for joining us, and really good presentation as all you do for LVGL is so great. We are very happy to have you here. Now, once again, have you help with our project. It was really important for us to have LVGL support on NuttX. Yeah,
Yeah.
it opened new doors.
Okay, likewise. Thank you very much for having me. And yeah, I hope you had a great conference and see you in person next year.
Yeah,
Thank
see
you.
you.
See you.
Thank you.
Okay, bye-bye.
Bye bye. Okay, I think we are mostly done for today, right? And guys, it was a long journey. 2 days of presentation, right?
Quite long.
Yeah. And this year we have 30 presentations. So it was really great.
I think that it was the biggest number of
Yeah,
presentations
for
that
all
we
the
had.
all the previous
Yeah.
year. Last year was 20 or 22, if not wrong. But this year we have almost 10 presentations more.
If we end up with more than 30 next year, probably we have to extend the event
Yeah,
to
maybe
3
days. Yeah.
It feels like it was a bit tiring. I see people being tired in the room.
Yeah.
It was more than a normal session. Also, we ran without pauses.
But you know, normally most people here are from Japan and they sleep all the time inside the metro or outside. They are not tired. They are just resting a little bit.
I think that we should also consider the people that watch it online and wanted to be live with us, because we had quite a high number of live viewers. And we should also consider the people that will watch it in the following week and months. So we will do our best. We will split the event into presentations, and then we will link it presentation by presentation to the schedule on the developer events, NuttX events webpage. I'm sorry, I'm tired. So that you can find the presentations that you need, and you can have an easy reference finding exactly what you need, especially since we had to run packed without pauses, and it may be a bit hard to navigate the material.
Yeah. And any other thing that we need to? Yeah, I think this year it was very complicated for people in Brazil, for example. I think we have a great audience there, right? Normally in previous year, we have 50, 80 or 100 people only in Brazil watching the presentation, the event itself. And this year, we saw it was they are not able to do that because it's in the in the middle of the night or after the midnight. So, but maybe next year in Europe, for example, it will be okay for everybody. But in the other hand, this time Japan, China, and India can attend more easily. Yeah.
This is the reason why we promise that we will have each year one event on each continent to be time zone friendly. And if we look at the historical statistics, we have around the same number of participants since we started the online workshop. If you count 24 hours, because some people will attend live, some people will watch in the first 24 hours to see what happened. So I think that overall we have a quite steady community, and we are grateful for having such a community, because that gives us the reason to organize this event. And we hope that next year we will get more people that are interested in helping us to organize the event, to become organizers. Like every year, we will post an announcement on the dev mailing list, and maybe you want to join. This year we had Hallison, which helped a lot with the organization.
Thank you for the help.
Yes.